Hello, everyone, and today we're going to go over some math skills with a Z because we're hip. So we're just going to jump right into it. We're not actually going to go over anything on PowerPoint or any note taking. So for today, we're just going to go over some basic math things that we could do. Did go over with the order of operations last time, so this time we're actually going to go over uh, some other basic math skills. One of the ones I do really want to go over is modulus. It'll be very, very useful for our next lesson in which we apply what we learned, part 2. So let's just get straight into it. So for this, if you want to understand what modulus is the remainder of something. It is the remainder of what something happens. So if I want to take the remainder, or let's say I have 100, or I have something that is 100. So therefore, now I have 127. And I want to get the last two digits. Well, I would say int x, or last two, equals 127 modulus 100. And what this does is this will take the 100, or 127, divide it by 100, and then if it can't divide it any further, it gives you the remainder. It doesn't care how many times it divided, it cares what is left after my division. So for this, if I just save and run this, see that the last two is 27. This comes into really handy if you're trying to break down a large number. So let's just try to break down a large number. So let's say int large num equals, let's go 1,754,892. I don't think that's the right number. 892. 1,754,892. And we're going to make an int digit equals new int 1, 2, 3, 4, 5, 6, 7. And what we're going to do in this situation, so what I've made here is I take my large number and I made myself an array of digits. There are 7 digits inside large number. And what I'm basically going to do is I'm going to store each digit in their appropriate number column. So, for instance, for int I equals 0, I less than digit dot length, I plus plus. What I'm going to do is I'm going to say digit of I equals large num modulus 10. Large num divide equal 10. I'm going to print out right here the digit I. So what I've done is I'm looping through how many the length of my digit array, which is 7, which correlates to how many digits are in a large number. And I am taking the modulus of the large number, modulus 10, which should give me the ones place at the time. And I'm storing it in digit I. Then I'm dividing it by 10. So I get rid of that ones digit. And I'm resetting it equal to large num. That's what divide equals does. Divide equals is basically the same as large num equals large num divided by 10. It's basically the same as that. So that's what I'm ending up doing. And then I just print out the digit at the end. And then what I can do is I can make an int sum equals 0. And then for int I equals 0, I less than digit dot length. I keep screwing that up. And what I'm going to do is I'm going to take sum plus equals math.pow of digit. All right, now of digit I times math.pow of 10 with I. So what this is doing is I take the digit that is in digit I, and I multiply it by the power of 10 of which it should be. And I add it to sum. And what I'm going to do is I'm going to print sum. I'm actually going to save this for later, just so we know what is all going on. So I'm going to take out the other print statement. And I'm just going to save this and run this so we indicate what is going on in the program. So we have 2984571 being printed out. If you read this from bottom to the top, we have 1754892, which is 1,754,892, which is the number that we wanted. So we did break it down by its individual digits, which in some cases you would want to do this. You would want to be able to store digits or store numbers that are expanded or further than the limits than any of your actual numbers can hold. And then you want to store it somewhere. So if I wanted to go above and beyond the limit of an integer, but I don't want to use decimal places, so I don't want to like use a double or a float, but I want to go above int for long, I want to go above that 64-bit, I can store it all in an array of 65 sections or above, and that's how I can store my number. So with this, I'm going to uncomment out the sum, and I'm going to show you how I'm doing the multiplication. And with this, I'm actually going to print out the sum in every instance. So if I just save, so I start out with 2, I add 90, I add 800, I add 4,000, I add 50,000, I add 700,000, then I'm at the total sum, and I break out of my for loop, and then I print out again. So this is basically just doing 10 times, or 10 to the power of the place, times the digit that is supposed to be in that place, and adding it to a sum. And then we're just printing it out. So these are two math skills that we want to know. So we want to know how to break down things digit by digit so we can understand or store them somewhere else if we want to go above limits. And we want to be sure that we can put it back together in the right order. And with that, we use the second for loop. All right, so that concludes today's video. I hope you guys all enjoyed. I will see you guys next time where we put our skills to the test in 3 different challenges.